Hey ladies. Okay, so here we're going to do some matching practice. So it's they're not the exact same questions from your test, obviously, but you'll go through the same process. So hopefully it'll give you a good start to it. But when you guys get to your test, make sure leave this till last, and then work with this afterwards. Just that way this doesn't. I think you guys were saying that it was kind of making you guys second guess yourself. So do the other stuff first. Leave this matching till last. Okay. Alright, so to start, where on earth will we start with this matching? So my first hint is, you know what, read through them all and then see if you, and then maybe there's some that'll look easier to you. Start with the easier ones and then work your way to the harder ones. Because if you go with those easier ones, you can start canceling, start canceling out, say for this first one, I can cancel this one if it matches with, say, B or something. Then you have fewer options and you'll kind of have a better idea of where to go. So take a quick, maybe I'll leave you 10 seconds here, quickly read them over, and then start with the easiest one, or maybe we can even just start with the first one. What can we do for the first one? So quickly pause the video now and take a quick read through all of those, I guess, little trig identities. Alright, so let's just even start with number one here. So let's look at number one. What could I do to this? Could I simplify this in any way that, if I simplified it, maybe it would look like something on the other side. But my suggestion is treat this like 6.1 or 6.2 where we just simplified. Don't try and look for immediately what it would match with on the right-hand side. So just start by simplifying. So if you look up here, we can simplify our numerator here by decomposition. We know we have a cos x squared, a cos term, and then we have that c term, so we can use decomposition for this. If you guys remember decomposition, you take your the coefficient of your first term and multiply it with the c term, I guess if you want to call it. So, and that would be your product. So you have 3 times negative 2 is negative 6, and then your sum will be 5. Okay, so that's just decomposition going back to even what we did last year. So what we're going to do is we're going to rewrite this numerator here as, rewrite this middle term here as whatever would be a product of negative 6 and a sum of 5. If you guys think about that, well, that is 6 and negative 1. Okay, so what we're going to do, we're going to write this as 3 cos squared x. We're going to rewrite this middle term here. So we'll do plus 6 cos x minus cos x minus 2. That's all divided by, if you guys want to leave the bottom for now, or if you guys want to, you can do this all in one step. This bottom here is a difference of squares, and if you guys remember the difference of squares, you take the square root of the first term, write that on your left side there. The square root of 9 is 3, square root of cos squared is cosine x. So you write that in your first term for each of those brackets. Then you take the square root of your second term, so it'd be square root of 1 is 1. Put that on each side, and then one sign is positive, one sign is negative. Okay? So from there, we're going to simplify our top. So you're going to group our 3 cos x squared plus 6 cos x, take out any common factors there. And there we have 3 cos of x. That is, what we're left with is cos plus 2. And then from our second group of guys, we can take out a negative 1. And we have cos x plus 2. And one thing you guys can notice is if you guys did this process right, these two brackets here should be they should be the exact same. That way we can factor it out nicely, okay? And the bottom, we can't do anything with that, so we're just going to leave it as it is. So we have 3 cos x plus 1 times 3 cos x minus 1. Okay, I'm just going to write over here. Hopefully you guys have some room there. Alright, so from there, let's pull out that common factor of cos x plus 2. What we're left with here is 3 cos of x and a minus 1. Okay, so hopefully you guys remember factoring and decomposition there. And then what we're left to on the bottom there, we didn't do anything there. It's simplified, I think, as far as we can go. So we have 3 cos x plus 1 and 3 cos x minus 1. Okay, from here, we're totally simplified, so let's start canceling some things out because we have some common factors there. So here we have 3 cos x minus 1 in the top and the bottom, so those will cancel out. What we're left with there is cos of x plus 2, divide that by 3 cos of x plus 1. Now that's fully simplified, so when you get to this point, or when you're getting close to that point, then you can look onto the right side here and say, okay, well, is there a cos x plus 2 divided by 3 cos x plus 1? Or if it's not there, is there maybe something that would be really close to that? So let's go through. So here we have 2 cosecant 2x times tan x divided by secant x. That would be a really far stretch. I don't know if we could even make that into an identity, so let's keep moving. B, we have sine squared, or sine x plus cos x all squared. And then here, moving down, we have cos x plus 2, divide that by 3 cos x plus 1. If you notice, this here would be simplified, and that is exactly what C is there. So for your first one there, that one is equivalent to, or that one there is a trig identity for C. Alright. So then, if you guys want to, you guys could look for which one you think you could solve next. But if you guys want to, start with just go down in a line. Can we solve, or is there something that we could do to B, or to number 2 here that would look like something on the right hand side? Okay. So looking at 1 plus 2 sine x times cos x, well, that one is kind of really tricky, and if you guys look at that, so if you look at this identity right here, that, if you guys notice, that is equal to sine of 2a. But what would 1 plus sine of 2a get me? Is there anything on your right hand side that would get you sine of 2a? And just by looking at that, I don't see anything that immediately comes to mind. So if this one, you're not sure where to go, you know, let's move on to the next one. How about number 3? We have sine squared x plus cos squared x plus tan squared x. Can you guys think of anything that we could work with that to move to, I guess, look similar to our right side? So if you guys can see that right away, there is one thing that we can do. It might be a little bit harder, but you know, if you maybe don't get it or don't see it right away, we can move on. But let me give you a hint here. So here we have sine squared x plus cos squared x. If you guys look at your Pythagorean identities, this here is actually equal to 1. So what we would go through is, so we'd have 1 plus tan squared x. This here is our squared term, so once again, you're probably going to go towards your Pythagorean identities. And actually, if you guys notice that, 1 plus tan squared x is equal to secant squared x. Okay, so that one there matches with D. If you guys didn't see that right away, you could always go back to when you guys got over to D, use your Pythagorean identities. So then what you'd have end up here, I'm just going to scroll on down. Here you would have 1 plus tan squared x. That is the identity for secant squared x. And then you can go backwards from there. So 1 is equal to cos squared x plus sine squared x. So replace this term here with that. Oh, that'd be cos squared x plus sine squared x plus tan squared x. And then you notice that it would match with 3. So if you couldn't see that right away in number 3, it might be a little bit easier to do that in D, but I guess these ones here, just remember you're dealing with, these ones here are all, I guess we're adding, and they're dealing with squared terms, so then you're most likely to be going with those Pythagorean identities, okay? So let's move on. Number 4, so if you guys remember those strategies I gave you, this one here is totally simplified, except for the fact that we could write this as 1 over cosine squared, or cosine of x. This one's pretty simplified. Let's leave this for now as it is, and maybe later on we can always go back, or we can do something with it, but it's pretty simplified, so let's leave this one as it is. So let's start going up to the top here, and I'm just going to quickly erase this here, just because we don't need that anymore. Hopefully you guys still have some room, or if not, write this on the back side of that paper. It's going to actually delete all this since it's not erasing nicely. Sorry. Okay, so for A here, what you could look at is another one of those strategies is use it in terms of sine and cosine. So let's start off by rewriting all of this as in terms of sine and cosine. So we have 2 times cosecant 2x is, remember cosecant is the inverse of sine, so we have sine of 2x. And then tan x can be rewritten, that's one of those reciprocal identities, or I guess quotient identities. And we can rewrite that as sine of x, divide that by cosine of x. That there is all divided by secant of x, and that is your reciprocal identity for cosine, so it'll be 1 over cosine of x. Okay, so one thing that is super important, this sine of x will not cancel with the sine 2x. The only way that that could happen is if this was sine squared x, but this is sine 2x, so we actually need to use that, rewrite it using that identity. So we can say that we have 2. Let's rewrite, we know what sine of 2x is. That is equal to 1 over 2 sine of x, cosine of x, and times that by sine of x, divide that by cosine of x. And this here, if we want to, I'm just going to rewrite this as divided by 1 over cosine of x. This will help us use that, or I guess our fractions, or division of fractions. So I'll just rewrite it like this, and also I'm kind of running out of room anyways. So, okay, I'm going to keep going below here in B. So here, just to simplify, we can start canceling out some terms. So we have 2 divided by 2 there. We have sine divided by sine. So what we're left with there is 1 over cosine times cosine is cosine squared x. Then we can simplify this here. If you guys remember, division of a fraction, you flip your fraction. So we have cosine of x divided by 1, and then change your sign, so it's going to be multiplication. So now what we can do is we have cosine of x, we'll cancel with that squared term there. What we're left with is 1 over cosine. If you guys want to, we just looked at 4. You know that the inverse of, or I guess the reciprocal identity of secant x is 1 over cosine x. You could rewrite b as that, or if you guys just already know that, we know that this one here will be b. Okay? And I don't ask you guys to show your work, so that should be totally fine there. And if I should write this, we had C up here, and we had D. So actually, at this point, what we're left with here is that 2 has to be equal to B. That's our only option, okay? So at this point, if you guys are just, oh my god, my brain's about to explode, you could leave it as this. You simplified, you found it to just one identity. I guess one on the left side, one on the right side. You could just apply that, say, you know what, obviously 2 has to be equal to B, but you could always double check though. To do that, just make sure that these two would simplify to one another. So I'm just going to erase this here. Alright, so another purpose that we could do this is that if B matches 2, then you obviously know that, yeah, for the most part, you probably did something right, but if you can make it match, or if you just say, you know what, this does not look like this identity, it could also say that maybe I did a mistake in a different step. Alright, but anyways, let's try doing let's try doing B, sorry. So here we have sine x plus cos x squared. So that can be rewritten there as sine of x plus cosine of x times sine of x plus cosine of x. From here we're going to use our FOIL. So we're going to distribute. And what we have there is sine of x squared. And then we have sine plus sine of x times cosine of x plus sine of x times cosine of x. And adding cosine squared x. Okay, so from here I'm going to simplify. We have sine squared x plus 2 sine x cos of x plus cosine squared x. And from here, this one might be a little bit trickier to see, but because we simplified, how can we make this b here look like number 2 here? So what we notice here is that actually we have this 2 sine x cos x. That is this guy right here. So now what we need to do is we need to get sine x squared plus cos of x to be 1. And actually, if you guys think about that, that right there is one of your Pythagorean identities, and we know that sine squared x plus cosine squared x is 1. So we can just rewrite that as 1 plus 2 sine x cosine of x, and there you have your identity.